Okay, I was asked to work this one homework question. First of all, it did not belong in the assignment, and I have removed it. You all got automatic credit for this problem. But it was number 6 in section 5152, but the reason it didn't belong there is because it actually came from section 4.3, and I did not assign you or did not intend to assign you any problems this difficult. Okay, so tickets for a certain show cost $17, $23, or for VIP seats, $39. If 8 times as many $17 tickets were sold as VIP tickets, and the number of $17 tickets sold was 54 more than the sum of the number of 23 tickets and VIP tickets, sales of all 3 kinds of tickets would be $44,118. How many of each kind of ticket would have been sold? There's a lot of information going on here. What we have is we have 3 different unknowns. We don't know how many $17 tickets we sold, or $23 or $39. So what I'm going to do is I'm going to set this up with 3 variables. My X is going to stand for the number of $17 tickets sold. My Y is going to stand for the number of $23 tickets sold. And Z is going to stand for the number of $39 tickets sold. Now, if I set up with 3 variables, I need to come up with 3 equations. Okay, so let's look here. If 8 times as many $17 tickets were sold as VIP tickets. Okay, well, the $17 tickets, that's X. That's how many of those. And VIP tickets, those are Z. Okay, well, there were more of these than these. 8 times as many. So what that tells me is that the number of $17 tickets is 8 times the number of VIP tickets. So 8Z. Okay. Now let's look at the next part. The number of $17 tickets sold, which is X, was 54 more than 54 plus the sum, that tells me it's an addition problem, of the number of $23 tickets and the number of VIP tickets. Well, this is Y and Z. So 54 more than Y plus Z. Okay, and then my last equation comes from here. The sales of all 3 kinds of tickets would give me $44,118. So if each one costs, so $17 for each of these X, so 17X plus 23Y plus 39Z is going to equal $44,118. This is the system we need to solve. Okay, there are a couple of ways we can do this. The way we talked mainly about solving 3 equations, 3 unknowns, would have been with elimination. So I'm going to rewrite this so that it's in the correct form for elimination. And with elimination, we want our variables on the left and our number on the right. So right here, I'm going to move this over to this side. Here, I'm going to move the Y over, and I'm also going to move the Z over. Okay, so this is X minus 8Z. I'm going to leave myself some space here because I'm going to line up the Y. And if I subtract 8Z from both sides, I have a 0 now. For this one, I have X minus Y minus Z is equal to 54. And then I have 17X plus 23Y plus 39Z is equal to 44,118. Okay, so here we go. I'm going to label these 1, 2, and 3. The way we did it, we solved these the first time, is we took equations 1 and 2 and we got rid of a variable. Now I could get rid of either X or Z. I can't get rid of Y because there's not one here. So it doesn't really matter. Let's say we're going to get rid of X. Okay. If I multiply this equation by a -1, that's going to give me a negative X there. And then that will cancel out with that X. Okay. So that gives me negative X plus 8z is equal to 0, technically -1 times 0. And then the second one did not need a change, so I'm recopying it. And now we add these together. The x's go away. I have -y plus 7z is equal to 54. I'm going to call this equation 4, and I'll come back to it. Okay, so we did 1 and 2, and we got rid of x. Now we need to take 2 and 3 and also get rid of x. So since I have 17 here, I'm going to multiply this by a -17. Multiply this entire equation by -17. That will give me -17x plus 17y plus 17z is equal to -918. And now I'm recopying this last one. Okay, and now when we add these together, our x's go away. And when you combine like terms here, you get 40y plus 56z is equal to 43,200. And I'm going to call this my equation number 5. Okay, so now what we want to do is we want to take equations 4 and 5 and get rid of a variable. If I look at these, it looks pretty easy to get rid of y. If I multiply that first equation, this one, by a 40, it should work. So if I multiply everything here by 40, I'm going to get -40y plus 280z is equal to 2,160. And then I'm recopying this one. Okay. Now the y's cancel out. Combine like terms and you get 336z is equal to 45,360. If you divide both sides by 336, we get that z must equal 135. So we have one of our 3 parts of our answer. We know now how many $39 tickets were sold, which are the VIP seats. Now we need to take this and plug it back in somewhere. If I plug it in here, I will get x very quickly. X is equal to 8 times z. So x is equal to 8 times 135. Which gives me 1,080. Now we need y. I'm going to plug in right here. X, which is 1080, is equal to 54. 54 plus y plus z. 54 plus y plus z, and z is 135. Okay. Now, if I, let's see, 135 plus 54 is 189. And now we subtract 189 from both sides, and you get 891. Okay, so how many of each ticket? Well, there were 1,080 $17 tickets, 891 $23 tickets, and then 135 VIP or $39 tickets. And this would be your answer. Again, I did not intend to assign a problem this difficult. I generally do not give word problems that require 3 variables, but I hope you were able to follow along.